I don't know how to, I mean, the question that I was asked to give a talk, and then I said, yeah, okay, I can do that. And she made me come up with a topic. And this topic, this change management, I thought that's something that I have been involved with and I have been doing. And as an engineer, it's very important, I thought. So I thought, okay, change management, engineering a life. It's just, I put it that as a question mark, and my question is also, basically it's a question mark to myself as well. Have we managed that? Have I managed that? What I have been trying to do. And what I've found really is that when you start thinking about it, about change management, at least for me, it came out as there is a contradiction here, because I am trying to manage a lot of things and I'm trying to stay without changing. So there is a contradiction. My management has always been, most of the time, trying to stay the engineer. So you're managing all that, trying to stay the engineer, where life itself is happening. So this is the question that I was wondering whether it was possible. And very often, I mean, when you think about it, I thought, yeah, John Lennon had it very nicely written in one of his songs, The Working Class Hero, when he said, life is what happens to you when you're making other plans. So I was making all my plans and life was happening. So I needed to manage. So how do we manage that? How can we manage that? I've always wanted to be an engineer, I have to say. At a very early stage, I thought, before I was even 15, I thought I wanted to be an engineer. And if I do engineering, I would do that. At that time in the Maldives, we were saying up to a doctorate. There's no postdoc stories or professorships or anything like that. So I've decided at a very early stage, okay, if I do it, I'll do it. And for me, there was no question about studying. It's not something that I pulled back away from. So I enjoyed that. So I started doing engineering, and then when I get to there's always a question, there's always not a question, there's always a thought that doing something, making something that is useful for the Maldives. I don't know why that always comes into my head. I'm not somebody who is, most people would say, a nationalist. I'm not that kind of person. I'm not a public figure either, and I don't want to be that as well, but for some reason, there is something that is useful for the Maldives. So when I was doing that, and I got to the last year of my BEng at University of Aberdeen in Scotland, and there I was given a choice. I was talking to my power electronics professor and said, look, I'm interested in a PhD. He thought, yeah, okay, let's do it. And then, you know, the process, it takes a whole year for him, for the discussion, and he keeps saying, your star is rising. Meaning that, okay, I've got a chance, I've got a good grade, get a decent grade and you're in. And the other thing is also, you're not really required to get a first. 2 2s will also get you in. And I thought, yeah, this is doable. And the topics at that time were very, well, he was coming up with electric drives for warships is one choice. The other was HVDC, high voltage DC direct current transmission. And both of them were very useful for the Maldives. And I thought, yeah, but there was another problem for me at that time. I was the Amnesty International Students President in Aberdeen, and the funding was coming from the Ministry of Defense. And this is electric drive for warships. And I had a problem, I had a serious problem, and I thought, no, I have to think about this. I have done, I thought all my life, I've believed in this so much, and do I change? What do I do now? And so I thought I'll take some time. I'll take about a year and think about it. And he also gave me time to think about it. And I have to say now, after that, when I came back to the Maldives after that. So when I came back and I started reading the newspapers, you see this in The Guardian, very small columns. Defense scientists dying. And 4 of them, one after the other, there was a series, and I thought, this is interesting. And they're the same color as me, and they have similar names, and they're in similar research. I thought, okay, it was a good decision, the Maldives. And HVDC transmission, I thought, no, we can't do it here. We haven't got enough engineers. it's better to do HVDC transmission, but we need a lot more. It's a lot more technical. We need a lot of electrical engineers for that, not just electricians, we need engineers. So I thought, okay, I'll do it here. I was in the Maldives, and I came, and I was basically in the Maldives, any industry that was the resorts, and I was in charge of looking after boats. And then after 1 year, I decided to go back. I looked up the professor, and he has gone back to Strathclyde. He moved to, and then, but I followed him up, and then he said, no, I can't come to him anymore. I ended up with another professor. And again, in that discussion, I remember now, I was sitting with him. I have to say it was a we decision, because he had topics, I had topics, and we were saying, and I said, look, I want to do something that is useful for electricity distribution. And he was saying, and then he came up with two choices. He had an expert system, and he had a neural net program, project. An expert system at that time, if you don't, an expert system is what you call an artificial intelligence system, but for a very specific area. For example, electricity distribution. You could do that, not the general AI that what you have here. That was the beginning of it, and we were doing smaller parts of it. And neural nets at that time was just theoretical. Nobody was actually building a neural net. The large language models and the GPUs and things were not there for us to play. And so that was one reason I did an expert system. And I developed an expert system. The title is an expert system for the optimal design of electricity distribution systems. And so that was a greenfield area. I could use that and build systems here. But when you look back and when you think about it now, hey, hang on, if I spend some more time on neural nets, the artificial intelligence, the large language models that are programming now would have been very easy to program. And on that. So, but that was, again, the decision was, my thing was to make something. It's buildable at that time. Neural nets are not buildable at that time. So that was the thing. And when you're doing programming and expert systems, that was a lot of logic. It went to an area that was not computing in that sense, but I had to learn a lot of programming languages, which were different, like the one programming language was Prolog, and the other one was Lisp program. So there's a lot of logic, and there was a lot of Aristotle. I like reading, so there was a lot of Aristotelian logic in it. And with all of that, I finished a PhD in optimization. And then when I come here and then think about it, you're trying to use that logic. And I thought, no, there are big changes here. And one thing I have to laugh, or at least makes me laugh, is there are more than 10 children in the top 10 here. That's a truth table logic that I can't get my head around. How can you get more than 10 in top 10? So these kinds of logic statements are probably not for the general public, and I find that in my life, at least, to be very serious about it. When you take an assumption like that, which is logically true, and when you're trying to base that on something that is not true, and you assume that is true, you're somewhere else. You're not in reality anymore. And for those students that you're taking as top 10, and I would rather be told that I am number 15, and next year I'm sure I'll get into top 10. If I'm in top 10 already, I'm in. What am I? I don't know who I am. So this is the whole reality of it for me, what came out with programming, with logic, with engineering, that there is a logical statement there. Any engineer will agree. There's a truth table. Your AND gates, your OR gates will always return a truth. So if you go in by that, I'm not saying that you become this holy person or anything. It's not that. You see the logic of it. You can't go against the logic. There are certain things you can't do. It will come back and bite at you. This is the thing that I faced when I came here. And at that time when I came, it was 96. And the only, I was given a job, but actually I have to say, yeah, I sought the job, and I was also given in at that time called MEB, and now which has become Stelco. There, the main thing turned out to be regulatory. Again, the regulatory framework that is in now, that was started when I started there as a director of planning, and was asked to head that in another department. And thought, no, again, this is the thing. Am I an engineer? I'm a regulator. I'm not interested in regulating. Okay, regulating is done to make sure that the engineers do their job properly. If I do my job properly, I am the regulator. So I thought, no, I'm not doing that. So I had my own company at that time. The only engineering level was carpentry work. And we automated that to all levels of we could. And I mean, we introduced pneumatic drills and all that kind of to make that. And then there came a bigger change that I had to manage. I got a daughter, and she had an illness, that a hole in her heart, and we had to change. And her mother is from Switzerland, and therefore the best place was Switzerland. And again, this was the thing, as an engineer, I had lots of issues at home. This is when you get a child, there's no manual, there's no instruction set, you don't know where the hole is. You really have to go through all the machines and scans and find out what's happening on that. So when I went back to Switzerland, went to Switzerland, and then there was trying to find a job as an electrical engineer, trying to stay as an electrical engineer. So I thought the best place would be to go to the university. I went to one professor and asked him, look, do you have any postdoctoral offers or anything? And then he said very nicely, look, for your type, he said, you've done your degrees, you're engineering, you're the PNs. In Switzerland, industry is much better. They pay you much better, and they will let you work. They will let you make things. Yeah, and he was suggesting automation industry. And in Switzerland, you have the choice. You have the ABBs, you have the Siemens, you have the Bosch, everybody. Yeah, so they were all there. And I was trying to find a job as an electrical engineer. Nobody wanted. And it was funny because I remember I got from ABB and Landis and Gear. These people, they have a very nice saying, yeah, I'll put your CV on hold and I'll get back to you. We'll keep it in file and then get back to you. These kinds of answers. So and I didn't know what to do, and then I gave my CV to an agency, see what they can find, what they do. And they had a look and said, why not software? I did not come up with it, and they said, why not software? And I thought, yeah, I could do that. I know all the languages, I can program. And to get into software was very easy, I have to say. After 2 months of looking for electrical engineer, I didn't spend even a day. I spent 6 applications before I could say it took enough time for the applications to land on their desk, and I had a job. I had a job as a software developer in a small company, and I started developing database software, and first was for UBS, the bank, private banking software. And then after 1 year, 1.5 years, I realized, life is okay, but this is not engineering anymore. The reason what happened was, for me, the side was, we were doing, as an engineer, you want the machines to yourself, but doing software for banks meant you're only given the databases on weekends. You're not the prime thing. It's somebody else's thing. You're fixing it. And I thought, no, I want to look for something that would allow me to make something. And then looking at engineering, I found Siemens was looking for electrical engineers with software capability, not software engineers. So when I joined them, I got the chance to go into a team to do real-time embedded software. Really and as an engineer, be involved with making something. And at that time in Europe, the rail network had to be harmonized. And what you have before was, before the harmonization, what you have is like if you want the train to come from Paris to Zurich, it's just the land is just a line across. But you have to change the composition, the carriages about 14, 15 times. and it takes a long time to come. So they harmonized everything, they wanted to control, and the project was to sending a train from Malmo in Sweden to Naples in Italy with all timetable stops, without a driver at 350 kilometers an hour, with all timetable stops, meaning all the safety of a rail program. So that was the project, and that was I was given that, and I got the opportunity that when I joined the company, I was given in that project, and the part I was given was train supervision. We were about 40 or 50 developers, software side, many on the mechanical side. I was given the train supervision module and the driver display module. These two modules, what they do is the driver is given a display, a touchscreen display, and displays what we call the braking curve, what the speed the train is doing, what his reactions are. And if he has to, the driver is given 5 seconds to react, meaning basically to touch the screen. He's not allowed to touch. Generally, what he's asked to do is sit and read his paper. If he doesn't touch in 5 seconds, or if he has to acknowledge in 5 seconds. If he doesn't acknowledge, the computer takes over. So we're coming in, if it's coming into a train station, if the driver doesn't slow down, and if he's too slow in going below the curve, then he's given 5 seconds. If he doesn't react, then I take over on that. So that was one part of it, of that. And the other part was the supervision part, which controls the train speed, the air tightness of the train, which is when trains go into tunnels at high speed, you have to shut down automatically all the doors and windows and make it airtight. Otherwise, your ears go pop. And all of these and then the another aspect was the train stopping. So you learn a lot of things. Yeah, the main aspect of what for me was you're doing real-time safety critical software. Every code that was written had to be written by us. Nobody was allowed to write any code or any copy from anybody. Every line of code reviewed by 8 eyes and everything. So that was, when you're doing that kind of thing, you want to go to work. You wake up wanting to go to work. At the same time, you think your work can kill somebody. If you're not serious, this is life and death. Your mistake is going to be, and then what I found was the place I was working at, and I noticed this later in Japan and in Switzerland. There is an announcement that they make. They will say there's been a personal accident on the tracks. That's very loosely put. I mean, that is the only thing that delays the trains in these two countries. Somebody committed suicide. And the driver, you have to, there is not something that we as control engineers or software engineers, we can't do anything against that. Somebody suddenly jumps in front of the train. We can't pull the train back that quickly. We can't stop the train that quickly. And all of this comes in. This is in the back of your mind. How do you stop these things? What happens? And the accidents that happen in other countries, in Germany it happened once. There was timetabling mistakes. These are mistakes that causes trains. Otherwise, there are no trains. You never hear about train crashes in Russia, in China, or even now in China, in Japan, and in Switzerland. Recently, there was the one in Portugal, a funiculare, one which is basically a train that is pulled up by a chain, and the chain broke. These things happen, so there are all of these. But then again, I mean, this is all well and good for engineering. For me, for my personal experience, this was very nice. This is a lot of development. But then as an engineer, you get to a stage. You go in that, this project is for 5 years, the project's finished. We've developed the product. The product is on the market. And for the developers, what we started getting was, and I was given this project, that project on the configuration. Like, for example, what comes up is there was Valencia in Spain wanted their trains, ETCS system. They wanted to improve their safety, so they said instead of, normally the trains have Two out of three computers, when they answer at the same time, he said yes. But the Spanish wanted 4 out of 6 with 2 driver displays. But for us, these are just basically configuration changes. There's no new thing in that. There's no new learning. So I thought, okay, I don't want to sit here for the rest of my life. It may be Siemens, it may be nice, but I want to do something. So trying to manage that change, I was looking for development companies, R&D departments that would do smaller projects, like 6 years, 6 months, or 1.5 years, or something like that. And then I found Metla Toledo. Their laboratory technology department was looking for, again, electrical engineers with software development. And they make weighing technology. And this division was weighing technology for laboratories, measuring for, basically measure nanograms or lower, yeah, on that, and measure equipment, liquids and things. So I applied for that and I got the job. And this thing about change management also came about. I got the job as a senior developer in the R&D. We were doing, and the first project I was given was, I think it was Novartis's pipette calibration machine was not working properly, and whether I could fix it. So I was given a machine that it had you know these, I think there was a toy that was a thing that goes up and then jumps off, fall off. It was like, I could play like that. Daily trying to fix this pipette calibration machine. It wasn't very interesting, but that was what they gave me on the first day. And then, after the probation was finished, I realized this was what we were brought. I was called to a meeting with 5 other people, and he said, we have a problem. The person said, we have a problem with the reason why you have been given the jobs and you have been selected is we have a problem with our quality. Our quality has been going down, and Metla Toledo wanted to improve their quality, and they got a group of people who had experience in change management. And I had to do a lot of change management in software and engineering. When you do safety critical, there is a thing that you call CMM, change management and maturity. How you manage your change, how you manage a product. How you change the product for the next day, and what happens to the people who bought it before. So these kinds of changes, and that was the reason I got the job. I had not the electrical engineering, it was the change management they wanted to bring. And with that, got a very interesting thing was he was given a chance to go and develop a metal machine in Shanghai with a Shanghai team. And for that, I was given, and I remember these are the few times that I had to go to CEOs. I could do with department heads and that level. I never wanted to mix with management. And I was taken there and told, you have to do this machine. The idea is, that was a time when in Europe, and it changes, that you could allow a certain number of parts to be made elsewhere and brought back into Europe and then put the country's name on it. And in this case, made in Switzerland. So we could take all of that to Shanghai, and I was given that project as to do the balance. Basically, what we were doing was, Metla has a series of balances, the expensive balance put into that quality software into a cheaper balance and sell it as made in Switzerland to the Chinese market at an expensive price. So all of this business came about. And I said, there are 2 projects here. One is the product development, the other is the team development in China. And with this experience, when I came back here, there was, I don't know, I can't say it is propaganda or media, or here everybody is saying Chinese quality is bad. And I said, no, I can't say that. I have personally gone there, done in Shanghai factories, quality good enough to be written made in Switzerland. So now I can't say 20 years later, the guys, we did it, they're doing bad quality. I can't say that. I mean, now, even at that time, they had quality that you're willing to pay for. If you're willing to pay for, they had that quality on that. So that was a very good experience on that kind of product management and all of that. And again, when that project was finished, after 5 years, In Switzerland, I found out that after 5 years, if you don't go up, you have to go sideways if you have to go up. You have to do something, basically. You don't stay still. You proactively have to do something. And that's how it's nothing bad in their culture that you don't, that, some people look to stay in 30, 40 years, one company. That's not the thing. You move around. The whole thing is the culture. There are many companies. There is the Siemens, there's IBM, there's Microsoft. Everybody's there. So you can pick and choose. You come back to the same department again. That happens quite a bit. So with that, for me, I was looking around and I got the opportunity here, again, to do renewable energy in the Maldives. And this, for me, was something that I have been looking for a long time to do on that. I mean, all the time I have been saying that we have enough energy here for all our needs. We don't need any to import. So I came back here to do renewable energy, and this is again a point where you're changing from an engineer, from an electrical engineer particularly, to energy. The whole concept of energy, the whole thing of energy, which is a completely different ballgame. It's not the electrical engineering anymore. So there was the renewables, and I also quite like it. And here we have, when I came back, and there was the promise, but this is the issue. We started with renewable energy, we started with a lot of things, and in this country we started by saying, at least from our side, from the energy side, was cheap energy for everybody. And I have to admit, after 15 years, I'm still waiting for that to happen. And it has not happened. It's not because of technology or anything, it's just for other reasons it hasn't happened. And we try, and our environment, we start talking about environment and the delicateness of our environment. We never consider ourselves. We want to protect the environment. Yeah. The thing is, as an engineer, I have to say, as an particularly electrical engineer again, you can never go against nature. You know the phenomena of nature and you're trying to harness it, and you learn to harness it. You cannot do anything else. Sooner or later, nature wins. But at the same time, I see this, and when I start talking like this, my daughter said to me, Tamara said, look, what you're saying is, you're worried that humans might die. The earth will survive. Humans might not be here. So the climate change, the whole thing, we're worried about humans, not the earth. I mean, I see the dilemma here. If you're worried about it here, we are destroying more, I see, than in the name of environment. All the resorts, all the reclamation that is happening now, and the regulations that are coming. And some regulations that are being brought in to protect is not, I don't feel that to protect the environment, not necessarily the environment. There are other purposes. As an engineer who want to produce something, it feels, because it is to protect a service industry. Not the production industry has been lost and it has been pushed down, and it will continue to do so. I mean, there are very simple examples. Fire, smoke. Every child knows. I mean, there's police now coming around if you put fire to something. But we import charcoal from India for 2.5 tons per day. We use it. This is we went so much against smoking and open fire burning by regulation, by media, by everything. We lost the art of making, the technique of making charcoal, how to improve on that charcoal, how to go from normal charcoal to carbon, how to activate that carbon. We lost all that. Limestone making, we lost all of that. We are never there. But now what they're doing is the same thing. They're building pyrolysis plants in Tilafushi, burning the whole thing again. But we could have done that. Now, without doing that, we kill our charcoal makers, and now we're importing from Malaysia, from Indonesia, from Philippines, And I can bet my last cent on it, the environment effect. The environment effect happens to everybody, not just to Maldivians. It happens to Earth. Not here if they're burning. I mean, this is the thing. Look at limestone making. I was taken once by the ministry to Japan as to serve renewable energy, and what they're doing at that time on that island, Tarakajima, I think it was called the island, they have a lot of lime in their water, so they extract the lime, and they're making an insulating material out of it. What we call our limestone that we do here. The same thing. Instead, we import all the material and destroy. And if you're really interested in protecting the corals, I can understand, then we wouldn't dredge this much. The amount of reefs, that would have been destroyed if limestone making was allowed to continue. The other funny, the more this is again the illogical side of it for me. Yeah, I was recently on an island. On every Maldivian island, we have coral which is pushed up onto the beach. In storms, every island. I can rake it and collect it and go and do something. When I asked, can I take it, nobody knew what to do. No, the council didn't know what to do. The ministry didn't know what to do. I couldn't find any regulation saying I can take this and burn this. But if I burn this at 900 degrees, I have calcium carbonate. And this is what we're doing, gypsum and all the putty and everything. We can add that to as a binder to anything. We don't need to import the cements and things. And we destroyed that. I would say as a service industry, got over the production, the manufacturing industry. And this comes at some stage it was bearable, I have to say. And then came the high end of it, where everything is served. And this goes against engineering, at least my engineering is, here we don't have enough people. That is also a complaint. So my solution would be automation. But automation is not allowed because if you automate, you can't charge. With service industry, if you serve the glass of water, then there's $10 in it, or there's a tip in it, there's something in it. That's the business model. But if you get it served, dispensed automatically, that $10 is not in the business case. So now we have sieving, very simple exercise. Not a single sieve I have seen automated here in the Maldives. Every day, how many cafes are doing for Roshi? How many cafes? Just the simple task of sieving. It's a 5-minute, 10-minute case for 50 kilo bag. The other is plastering, cement plastering. And I can go on and on and on, about automation levels. But the level is not used because it goes against our business model, the service industry's business model. For anything I'm working now in Tilafushi, basically I'm making char, activated charcoal and activated char, and I built a pyrolysis plant myself, and if somebody asks me whether there's smoke, there's no smoke. There are 3 stages of burning. So there will not be any smoke, and smoke comes out because there is unburned material. I'm burning with 3 flames and there is no smoke. And there, all the people that I see yesterday, I thought this was not possible, this is not available in the Maldives. I went around to buy something and then I had to go to Leo Trading's site, the dockyard go down they called it. And when I went to the go down, actually by chance I saw they're building ships. They also build ships. The Leo does that, Hawks does that. Do we have welders? We don't have welders. And all the welders are imported. $3,000 is an automated welding plant. And it's robotic. Now robot arms can weld. And the only thing is why they don't try is it's not the automation. It's the belief that, it would have to be a person. The belief in the automation is not there because everything is served. I think I can go on and no, that for that is the one reason why all of this is like this. So when it came to the Maldives, so the main thing for me was again trying to stay without changing, moving away from this. At least I have to say, try to stay the engineer. This time I had to do not to become the consultant, not to become the politician. So this was the reasoning, my reasoning, trying to stay as the engineer. And as an engineer, I see more changes coming, which I fundamentally would like to jump on. I'm trying to jump on. Quantum computing is going to come. Things going to change much, much faster than what we have. Our generation have been very lucky with change. We started with fixed dial phones and now we've got this. So we can manage the change. And I think anybody, if you really think about it, there are two basic things. You want the change, not necessarily when you have to. Always, because change is the only constant. That is always there. Every day it is. But because it is there, you don't want to go along. You manage your change and try and stay. So that would be what I have to say. Focus on your thing and do what you like, and then you can manage the change. Thank you very much. Yeah.